Hello, in this video we're going to take a look at sketching the graphs of sine, cosine and tangent, and I'm going to do this with quite a nice animation that will hopefully make it quite clear to see where these graphs come from. I'll timestamp each one below, so if you specifically wanted to see the graph of tan, you can go straight to that one, and if this video is useful please do go over to my channel where I have loads of other maths tutorials. So to get an idea of where the trig graphs come from, we're actually going to start off with a unit circle which is centered at the origin. So if you're unfamiliar, a unit circle is just a circle that has a radius of 1, and so I'm going to mark that on like so. Now using this radius, I'm actually going to construct a right angled triangle, and the way I'm going to do this is by making a perpendicular line like this with the x-axis. So hopefully you can see now this shape here is my right angled triangle. Now I'm going to focus in on the angle between the positive x-axis and the radius, so that's this angle here, and I'm going to call it theta. Now if you think about the trig you've learnt to do with right angled triangles, what would sine of theta be? So what would sine of theta be? Well, that's just the opposite side of my right angled triangle divided by the hypotenuse. And if I label those up, well, the opposite side is just opposite the given angle, so that's my opposite side. And the hypotenuse is the longest side, or the one opposite the right angle, so here is my hypotenuse. And I know that the hypotenuse is length 1 because it's the radius. So let's rewrite this. So it's the opposite side, which I still don't know, so I'll leave it as the opposite. But that's now divided by the hypotenuse, which has a length of 1. And any number divided by 1 is just itself, and so we found out that sine of theta is just equal to the opposite side. And so let me rewrite that in. So the opposite side I could say is equal to sine of the angle. And so now what we could say is, well, the height of this triangle, or the length of this side, if we look at what happens to it as we change the value of theta, that tells us what sine of theta is equal to. And actually I've got an animation that we're now going to look at that's going to kind of show us how we could use this to get an idea of what the graph looks like. And as we look at that animation, I'm going to fill out the graph over here. I've recreated the unit circle we were looking at, but I've done it in this software so that I can now move around this point P, which will enable me to change the size of this angle. So let's focus on a few key points. So maybe we'll start where theta is equal to 0. Okay, so when theta is 0, what is the height of this right angled triangle? Well, when theta is 0, we don't even have a triangle, do we? All the points will lie on this flat straight line, and so the value of sine of theta, or the height of this triangle, is going to be 0, isn't it? So I could mark that on. Now, as I increase the size of the angle, you can see I make the angle bigger, you can see the height of this right angled triangle is getting taller. So sine of theta is going to increase, and it's going to keep increasing until we get to 90 degrees, when this angle is 90 degrees, because now the height of this triangle, or I guess it's a straight line now, but the value of this is going to be 1, isn't it? It's at its peak. It's now at a height of 1, so I can mark that on when it's at 90 degrees. Now, as I keep increasing the angle, so we're still focusing on this angle here between the positive x-axis and the radius, you can see the height of this right angled triangle is now decreasing, and it's going to continue decreasing until it gets to 0 again when we're at 180 degrees. Now let's keep increasing the angle, and you can see it's going to start becoming negative. Okay, so even though it's a height, we'll still say the actual value is negative, and it's going to keep getting negative until it reaches -1 at 270 degrees. So again, I can mark that on. And then as we increase the angle more and more, you can see it's going to start getting closer to 0 until at 360 degrees it's 0. Now, if you've seen sine of theta sketched before, you'll know that it just goes on infinitely in either direction. So what's happening there? Well, say we were to look at sine of 450. Okay, well, that would just be going round to 90, 180, 270, 360, and then back round again to 450. Okay, and so all that's happening is it just keeps cycling round. Now, you've probably also thought that there's negative values that you can put in. Well, that just means going clockwise round rather than anti-clockwise. So for example, sine of -90 would be, well, we go round 90 degrees in the clockwise direction, it would be -1. Okay, and so this graph goes on forever, and it's what we call a periodic function that we'll talk about a bit later on. And so now we've got an idea of what sine of theta looks like. We're actually going to go back and take a look at cosine of theta. Okay, so what we're going to do now is go back to our unit circle, and we're going to use this again, but this time to find the value of cosine of theta. So let's think back again to our GCSE maths, and what was cosine of theta? So cos of the angle Well, that was just the adjacent side divided by the hypotenuse. So let's label up the adjacent side on this right angle triangle. Well, that would be just the base length here, the adjacent. And so we don't know what the adjacent side is, do we? So I'm going to leave that as the adjacent. But remember, we do know the hypotenuse. The hypotenuse has a length of 1. And so we get that cos of the angle is equal to the adjacent side divided by 1, which must mean that cos of theta is just equal to the adjacent side. And so actually I'm going to get rid of this and rewrite that adjacent side as cos of the angle. Now what I'm going to do is go back to that software and do the exact same thing. I'm going to change the value of theta, and as I do, we're going to see what happens to the base length of this right angle triangle. And as I change it, I'll be marking on the key points again, but on this graph here for cos of the angle. So you can see I've got the same kind of situation set up here again, except this time I have cos of theta labelled, so the base length of this right angle triangle. And we're going to see what happens to it as I change the angle here. Okay, so I move P around the circle, that's going to change that given angle. So let's again start off when theta is equal to 0. And so let's move P down to the x-axis. You can see that angle is now 0, and again we have these points on a straight line. And when that happens, you can see the length of the base, or I guess the length of this line, is just the radius of this circle. And so we get cos of theta is equal to 1. Let's now increase the angle. And you can see as I increase the angle, the value of cos theta is decreasing. It's getting smaller and smaller until we get to 90 degrees, where the length of cos theta is 0. So we can mark that on. Let's keep making this angle larger. And you can see as I do, cos of theta gets more and more negative. And it's going to keep getting more and more negative until we get to -1 at 180 degrees. Again, I'm going to keep increasing the size of this angle, and as I do, you can see the length of cos theta is getting closer and closer to 0, and in fact at 270 cos of theta is 0 again. And then as I keep increasing the angle, you can see cos theta is increasing, and it's going to keep increasing until it gets back to 1. Okay, and I can mark that point on. So to sketch our final graph, the graph of tan of theta, what we're going to do is go back to our unit circle one final time, and we're going to write down what tan of theta is. So tan of theta, well, that's just the opposite side divided by the adjacent side. And so what is the opposite side of our right angle triangle? Well, that's just sine of theta. So let's write in sine of theta. And what is the adjacent side of our right angle triangle? Well, that's just cos of theta, or cosine theta. Okay. And so we're going to use the fact that tan of theta is equal to sine of theta over cos of theta to get an idea of what's happening to the graph as the angle changes. Okay, and I'm going to go back to that software one final time, and as I go through the different values of theta, I'm going to be adding points onto my graph. Okay, so let's see what happens as we change the value of this angle here, theta. Now remember, tan of theta is sine of theta over cos of theta, like we saw. And so let's start off when theta is 0. Well, when theta is 0, we can see sine of theta is 0 and cos of theta is 1. Okay, and you can actually see that looking back at the previous two graphs that we had earlier. And so this is just going to mean that, well, when theta is 0, tan of theta is just going to be 0 divided by 1, which is 0. And so I can mark that on. Now let's increase the angle theta, and as I increase this angle, well, sine of theta is getting bigger and cos of theta is getting smaller. And when you're doing a bigger number divided by a smaller number, your output is going to get bigger and bigger. And as this angle gets closer to 90 degrees, you can see we're doing a number that's nearly 1 divided by a really small number. And that's just going to get really big very quickly. And this is actually going to tend to infinity as the angle tends towards 90 degrees. Now, we do actually have a problem when we have the angle being 90 degrees. And the problem is, well, sine of theta is 1, that's fine. But cos of theta is 0, and you can't divide by 0. And so we actually say that the function is undefined at this point, and we get this asymptote as it's tending up towards infinity. Now, let's keep increasing the angle. So as I increase it a little bit more, you can now see that, well, I've got a relatively big value of sine, it's pretty much 1. But again, a really small value of cos of theta, but it's negative this time. And so this is going to result in a really big negative number. And so it's going to ping down to negative infinity. And as I increase that angle more and more, what's going to happen is the value is going to get less and less as I approach 180 degrees. Because you can think at this point, well, sine of theta is nearly 0 and cos of theta is approaching 1. And as that's happening, we're getting closer and closer to 0. until we reach 180 degrees where sine of theta is 0, and we get 0 divided by 1 again, which results in 0. Let's keep increasing this angle more and more, so theta is going to get bigger and bigger. And as we do, let's think about what's happening. Well, I have a negative value of cosine and a negative value of sine. So a negative number divided by a negative number is a positive number. And as I increase this angle, you can see sine of theta is getting bigger, cos of theta is getting smaller. And so we're going to tend up towards infinity again. And as theta approaches 270 degrees, you can see tan of theta is going to tend up or tend off towards infinity. And again, we have another undefined point when theta is equal to 270 degrees, because again, we can't divide by 0. Now in the final stretch, as theta gets bigger and bigger and bigger, you can see what's going to happen here. Well, sine of theta is going to be getting smaller and cos of theta is going to be getting larger. So it's going to start off around here at basically minus infinity, or in the negative value. And as we increase the angle, it's going to get closer and closer to 0 until at 360 degrees we hit 0 again. And so just to summarize, because these sketches are fine, but they are just sketches, I might actually have some really accurate pictures of sine, cosine and tangent for you to have a look at. So if this video was useful, please do go over to my channel where I have loads of other maths tutorials, and actually I'll link my website in the video description so you can go over there and it might be a bit easier to navigate all of my videos in one place. And thanks for watching.